Hello and welcome to another video. In this one, we're going to be talking about all-repos, which is a tool that I wrote, and I'm going to kind of talk through the reason for writing this tool, as well as a small, demo, and yeah, hopefully it goes well. Anyway, let's jump into it. All right, so in order to frame why I wrote all-repos, I've actually written it 3 times now. The first time I wrote it was when I was at Yelp, and it was during a period where Yelp was transitioning from a monolith to microrepos. I guess I should probably talk about what all that means first. So first we're going to talk about what monoliths are. The idea behind a monolith is that, when a company starts out, you never really realize how big it's going to be, and so often many companies start by just having one large repo where they throw everything into there. And Yelp was, pretty similar to this. There was a big repository called Yelp Main, which had both, the desktop site, the biz owner's site, the mobile API. Basically, everything was thrown into one repository. And this was really convenient when, Yelp started out. Like, this is convenient for a lot of companies. It's really easy to, take one repository and make that one work well. When you start introducing lots of other repositories or multiple repositories, you suddenly get into more like deployment issues and all sorts of other stuff. And I'll actually get into more of that later. But as a company grows, a monolith doesn't necessarily, solve all the problems that you would want to solve for a company in particular. It can be really hard to figure out who owns some things. You get a lot of, ambiguous owners like, oh, who do I poke for this particular file? Well, you don't really know unless you happen to know the entire code base and happen to know everyone that works there. Now, there are other systems around this, like you can probably mark files or build another system on top of this, but on its own, monoliths kind of make this difficult. It's also slow to iterate and develop as this single repository grows and grows and grows. Its build gets slower and slower, its deployment gets slower and slower, because you tend to have one big artifact that you're deploying somewhere, which has its other problems as well, like performance and other things there. But yeah, and lastly, and there are many other problems with monoliths. These are just the 3 that I decided to throw out there. The last is, as a repository grows to a particular size, your version control system may have trouble keeping up with a particularly large repository. For instance, Git, although they've been making a lot of changes recently to support larger repositories, notoriously does not support big repos all that well. And usually when you end up in this situation with a monolith, you usually the popular solution is to go to microservices. And there are kind of 2 different approaches to microservices that I've seen popularized. One is monorepos, which we're not going to really talk about today. Beyond that, monorepos are basically a single repository, but there are many repository-like things inside of them. So you have independent components all versioned in a single repository. They have their own sets of problems, their own sets of infrastructure that you need to build to support them, but we're not gonna talk about them today. The solution that I'm much more familiar with is microrepositories, which microrepositories for microservices. The idea behind microrepositories is you have many services, and each of your services has its own repository, and it is its own independent deployable piece. And this has some benefits, like it's much easier to deploy them because you can deploy them independently, and like ownership is unambiguous because your team owns this entire repository, and the version control system tends to scale better because you're dealing with a very, very small repository. However, they're not they're not without their downfalls. So here are some of the problems that microrepos have, in that it can often be difficult to find code. Say you're one service that calls another service. You want to know, oh, well, where is this endpoint to find? First, you have to figure out like what repository it's in, which can be difficult to find sometimes. And then you have to find like what file it's in, and traversing code boundaries can be quite difficult. With many, many repositories and many independent owners, it can often be difficult to make sure that all of the stuff looks about the same. So there's a lot of drift that's easy to have in small repositories, especially because like as you bootstrap new ones over time, and you have like some base template. That base template is going to change, and so often it's difficult to keep them all in that same, structure and design. And lastly, sweeping changes are really difficult because on the tin you have to go to each of these repositories and apply the same change over and over, and that can be either very tedious or something that's just never pursued because it's difficult to do correctly. And these particular problems are the original motivation for writing all repos. As Yelp switched to having micro-repositories and microservices, both libraries and services, so not just services, we started to encounter a lot of these problems. It was often difficult to say, like, oh, where does this particular piece of code live? And, how do I fix it? How do I fix it everywhere? And this is where I originally wrote the first closed source version of all repos. Now, that wasn't necessarily the only use case for all repos. I actually had my own personal use case, which triggered the second version of this, because I left Yelp at some point, and I maintain a bunch of different open source things. And the second iteration of all repos was a tool to make it easier for me to maintain lots of open source repositories, because they have a lot of the same problems as micro repositories have at companies. You have a ton of them, they all drift ever so slightly, and it can be really difficult to figure out, oh, I know I wrote this somewhere before, where do I find that piece of code? And so all repos was also a solution for me to solve the micro repository problem, but for open source. And I guess now we'll just jump in and show you a little bit of a demo of all repos to show you how to get started, some of the tools and command line helpers that it provides, and how to go about auto fixing something. So let's jump into that. Okay, so I'm going to just start with a blank a blank directory here. You can see we've got nothing here. And the first thing I'm going to do is I'm going to install the all repos tool. So I'm going to set up a virtual environment and activate it, and we're going to pip install all repos, and this should bring in the all repos command line. You'll see that it has a single dependency on identify, but for the most part it's pretty self-contained. It should work on Windows, Mac OS, and Linux. The testing outside of Linux is significantly less, but it should work on all the platforms. People have confirmed that it has worked there before. Now, the first command that you're going to run in all repos, I guess I should open up the README and kind of show you where it lives. It's on my GitHub, so you can search all repos GitHub and get to acetility/allrepos. And it has a bunch of command line tools and a bunch of configuration. The README is pretty long, so I'm going to go over most of the basics of it, and you can read the rest of it at your own pace. So the first thing, the first command that you're probably going to run in all repos is all-repos clone. This is going to take all of the repositories that it has access to and clone them to disk. Now, of course, when we run this for the first time, all-repos clone, I think it's stack traces. Yeah, it's still stack traces. I probably need to make a little bit better error messages here. But the first thing that we get is that there isn't an allrepos.json, and most of all repos is driven by this particular configuration file. This specifies, what repositories you're going to clone, and the clone, or what is it called? I forget what it's called, but we'll look at an example configuration and start by cloning that. So let's copy. I'm actually going to copy both of these here. There is. Oops. Oh no, I splatted over the wrong one. Shoot. Well, we'll do this live. Let's see, all repos. Okay, not JSON. This is the one where I I blanked out the credentials so that you can't really see what it's going to do. I blanked it out so that you can't just steal my creds. But there is a few configuration options that happen here. The first and the most important one is the source. This is how all repos is going to clone repositories. There's a bunch of different sources, and you can write your own if you had, a special one-off source. I'm using the GitHub source here, which is going to clone every repository that I have access to. For that, you specify an API key. This is what you'll use to, scrape the repositories from GitHub. The username actually is technically unused, but can be used for some stuff if you need it. And I say collaborator true. This, will include other forks. I actually don't need collaborator true for this, so I'm going to leave that out. That's if you want repositories that you have contributor access to, but don't explicitly own. And you can filter down the repositories. So I'm saying include everything in Acetilli, but we're going to filter out ancient Pythons, particularly because this one is large and I rarely care about the contents of it. So we're going to filter it out. We tell it where to output these repositories. So we're going to put it in a little repos directory. And finally, there's a push module here. This specifies how repositories are going to get pushed if we do a distributed refactor, which we'll get to later. So that's the all-repos config. I hope that this config has the credentials. If not, I'll have to do some surgery. All right, but the first command we want to run is all-repos clone. This should clone all of our repositories. And key error source. Oh, this means that the all-repos config is broken. Give me 1 sec while I fix this up. All right, fix that up. Opened up this file. I added the one line that was missing. So now we should be able to do all-repos clone. And what this is going to do is it's going to reach out to the GitHub API. It's going to find all of the repositories that I have access to, and then it's going to clone them all on disk. Now, I have quite a few repositories, but this should still complete pretty quickly. It clones them in parallel, so it's a little bit faster. But it's going to basically clone everything that it has access to. There was an error that happened there. That's because I have some empty repositories. Empty repositories currently aren't clonable, but I don't think you would want to do sweeping changes on empty repos anyway. Okay, cool. So now we have cloned all of our repositories. And if you want to, update all your repositories, you'll rerun all-repos clone. I'm not going to do that here. The next command that I'm going to show you is all-repos list repos. This kind of shows you all of the repositories that you just cloned down. So you can see there's quite a few here. And the way the commands are designed is they're designed to be composable, so you can run them, and pipe their output into other stuff and use them in combination with each other. Now, the tools that I find much more powerful than just, cloning and, okay, here, you have them all on disk. All-repos provides a bunch of distributed searching tools. The first of which is all-repos find files. All-repos find files. And so what this will let you do is it will let you search for files by file name. So let's say we wanted to find all of the repositories which have talks configured in them. So we can do all-repos find files, and you'll see that it can print out all of the repositories that we have here. We can also specify some command line options to just show the repository name or just show the path. So if we just do repos, you'll see it'll just have the path here. If we did output paths, I think it is, yeah, then it'll use a slash instead of a colon here. That way, if you needed to pipe this into another tool, you can very quickly do this. So like say I did at -5 and open those in my editor, for instance. This will let me view those files pretty quickly. You can see that even with all repos, there's still some amount of drift here. Actually can get rid of this in this file. Maybe we'll do that as a distributed refactor later. Okay, so that's all-repos find files. There's also all-repos grep. This is the one that I like the most. Let's say we wanted to find my modules which use tokenize RT, for instance, in Python files. So what this is going to do is it's going to run git grep against all your repositories. And again, like there's lots of output here because there's lots of imports. And so again, you can filter this down to just repos, or as do -L to just get file names, and output paths to put slashes there, etc., etc. So you can see all of the places that this particular thing is defined in. So it's really easy to discover code across different boundaries here. But I think the thing where all-repos shines the most is its distributed refactoring tooling. All-repos provides a few distributed refactors out of the box. The most useful one is all-repos sed, which allows you to basically run a set expression against all the files. So let's actually take that example from before. All-repos grep show missing in talks.ini. So first we want to filter down to the repositories that have this, and it is these 3. And I actually have this defaulted in all of my repositories based on a coverage plugin that I wrote. So let's do -- repos here. So we just get the repositories here, and we're going to do all repos sed. We're going to do dry run first because we don't want to have the side effects. We're going to replace show missing with nothing globally in talks.ini files. And we're going to select our repos based on this search that we did up here. And this is, again, like being able to combine these various commands together and make them work better. So this is, splatting all of the repository names into the repos argument. So this should run unrecognized arguments. Oh, right. So this one doesn't take repos. So it just runs against everything. Wait, really? I could have sworn this had a filter on it. Yeah, -- repos. Oh, it must be because I put the -- here. There we go. And so now it's going to clone and apply that distributed change automatically. And if I wouldn't have done dry run, which actually, I want to make this change anyway. So now that I verified that it's good, I can remove dry run, and it will actually go and create pull requests on GitHub for me. So you can see here, it pushed, and it'll actually end up, if we go to GitHub and we look at pull requests, you'll see that it has the default commit message is not great. It's very literal in what it's doing. I probably should have done commit message so that it didn't do this particular one. But you can see that it has gone out here and it has, created a pull request that's removed that particular, argument from each of these. And these will all look basically the same because they're all the same change being applied over and over. But yeah, that's kind of the very basic of refactoring. You can also write your own refactors of these. There are a bunch of examples in the all repos repository itself, so you can click through some of these. Some of these are based around pre-commit, like auto-updating your configuration or migrating your hook configuration or other stuff like that. But all repos gives you some library functions that makes it easy to write your own auto fixer. Basically, it's 2 parts or 3 parts. One is your command line parsing if you need custom command line stuff. An apply fix function, which runs inside of the repository, can change whatever you want, and a find repos, which will give you the default set of repositories if you don't want to, do -- repos like I did here. So it allows you to filter the defaults down. Yeah, I've also used all repos sed and provided a few examples on the all repos incantations repository, which goes over some examples of where you might use all repos sed directly. These are kind of the simpler ones. So you can see, like, back when I used Travis CI, which I guess this hasn't been updated in a while, you can see some of the, diffs and commands that I ran and maybe take inspiration from some of those. Here's like a slightly more interesting one where it replaced, well, I guess it's not slightly more interesting. It's just a set expression. And there's a bunch of other tools that all repos provides, just a few others to mention quickly. All repos complete gives you tab completion for clone. So if you want to, git clone // something, you could do, git clone g tab 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 // tab 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 and get your list of repositories there. There is also all repos manual, which allows you to do a distributed refactoring, but you manually drop into each repository. I think that's all of them. All repos sed, yeah. And then there's a bunch of other ones out of the box. Also, you can configure your source and push modules in a bunch of different ways. There's a few out of the box. So there's the GitHub one. There's this JSON one. It's kind of a dummy one, mostly used for testing. You can clone everything that forks a repository. I used this to find a microcontroller that was doing a particular set of things. You can clone a specific GitHub org. I actually used this for my startup, Precommit CI. So I have configured Precommit CI to just clone the Precommit CI repositories. So I have a way to make sure things are up to date there. So let's say this is one that I know I've been putting off. I need to upgrade cryptography to be all at the latest version. You can see I have a little bit of version drift here, but I can easily write an all repos auto fixer to make this upgrade across everything. But yeah, that's all repos. That's the things that it solves for me, particularly maintaining all of these repositories. But it also might, make maintaining microrepos at your company easier as well. But anyway, thank you all for watching. If you have additional questions, reach out to me on the various platforms, and I will see you in the next one.